Good evening. I'm going to go ahead and talk about lesson 20, and that's hypothesis testing for population means when your population standard deviation is known. So for this to be certain, you have to have certain parameters that you need to follow. You need a simple random sample, which means there is no bias in the way the sample was created. You have to have the population standard deviation, and it's known. This is extremely important, and I can't stress on this enough. So when you get into that final exam or you get into that next test and you're looking at hypothesis testing and you're confused about which one to use, the first thing you look at is to see if there's a population standard deviation. And if you see that you have that population standard deviation, and it will say that, it'll say population standard deviation is this, that's how you know that you're going to use a z-test, what we're going to talk about in a few minutes. And you also have a sample size that is 30 or greater or normally distributed. Normally distributed goes back to that inverse norm and that normal CDF function that we used back in module 3, which if your data is normally distributed, it makes that really pretty bell-shaped curve, and we can make a lot of assumptions based on that kind of distribution. So let's talk about the three types of hypotheses that can be made, okay? HO is the null hypothesis, and I have HA here. It's also H1. For Ecore, the book we use, it's H1. I've also seen it used as HA. So for us, let's use H1 so we don't confuse you. You have a left tail test, a right tail test, and a two-tailed test. The big deal about this is in your alternative hypothesis, the only things you can have is the less than symbol, the greater than symbol, or the not equal symbol. Always and forever for you with your null hypothesis, it's an equal symbol. So you don't have to worry about anything else. It's always going to be equal. So that should make your lives a lot easier with what you guys are doing for hypothesis testing. Okay. So let's go ahead and talk about the different things that it can be. So let's look. All right. So population mean is described by the mu symbol, and that's what's used in the hypotheses. Your sample mean is X bar, and that's the mean of the sample. Sample size is N, and it has to be greater than 30 or equal to 30 to use this test. Your population standard deviation is going to be given with a sigma, and your level of significance, alpha, or your level of confidence, C. And there's a relationship between these two. Your level of significance will help you lead yourself to what level of confidence you have. And we'll get into that once we get to a problem. All right. So if you're going to put stuff into a calculator, what you're going to do, and let me walk it through you with the calculator. Okay, here's my calculator. So to get to it, you're going to go to stat. All right, let me turn it on and let me clear it. So you're going to go stat, and I'm going to scroll over to test. It's the first test you come to, z-test. And remember, we use z-test for population standard deviations. I hit enter. Okay, there's two ways we can do this. We can put in actual data or we can put in statistics. If you put in actual data, it's going to go down here to list L1, and that's where you've put all your data in is L1. The frequency will always be 1, okay? We're going to do an example of this in just a minute. Now, if you do stats and you have to, when it's blinking, you have to hit enter to make it take it. And then you'll see here there's no L1 or frequency of 1. So let's keep scrolling down, and I have some examples in here, and let me show you how to put this into the calculator. And we're going to work through one of these problems all the way through. But before I get there, let me talk about your level of significance and your conclusion. Your level of significance, whether it's 95% or your level of confidence, it could be 90% or 95%. That is directly related to your level of significance. If your level of confidence is 95%, you convert that to a decimal, which makes it 0.95, and you subtract that from 1. 1 minus 0.95 gives you 0.05, which is your level of significance. Remember, any p-value or any value you talk about on the normally distributed curve, has to be 1 or under. All right. We'll come back to that when we do the problems. To conclude your results, here are the rules that they have. If p is less than or equal to alpha, you reject the null hypothesis, which means the alternative is true. If p is greater than alpha, you fail to reject the null hypothesis, and the null is true. The way I remember this, and I even do this, and I have a master's in this stuff, is people eat fish from the River Nile. People's the P. Eating fish is like the little Pac-Man symbol with the little equal sign under it. Fish is the level of significance, the alpha. And the River Nile comes from reject the null. That's the way I remember it. I know it sounds silly, but if I remember it that way, if I know the rule to reject my null, then I can base everything else on that. Okay? All right, so let's do this one together. It's believed that the average, that the average student spends 20.5 minutes on Facebook every time they visit. The standard deviation, the population standard deviation is 8. A simple random sample of 150 visits had a sample mean of 22. A professor wants to know if the mean time on Facebook has increased. At the 0.5 level of significance, what conclusion can be made based on this p-value? Okay, we have hit all of our parameters right here because we know that it's a simple random sample because it tells me right here this is a simple random sample. Okay? And it also tells me the population standard deviation right here. Okay? Let's do this. And then it told me it was a simple random sample, which is great. And it also told me that my sample size was greater than 30. So I have concluded that I have all that stuff in here. Okay, so let's see what else I need. Let me see what kind of direction it's going to be. Well, I have here that the professor wants to know if it has increased. So I'm going to do if the mean time has increased. And let's go ahead and do that. So that means it's going to be a greater than, because if I want to see if something's increased, it's going to be greater than it. It's going to increase over something else. So the first thing I do is make my hypotheses. So for my null, it's my mean equals 20.5%. But you're probably wondering where I got that. So let's talk about this. I know my population standard deviation is 8. I know my n is 150. I know my sample mean is 22 because it says that, a sample mean of 22 minutes. I know I have a 0.5 level of significance. Well, because I already have my sample mean and my population standard deviation, my n and my level of significance, the last thing I need is the average time, which is my population mean. If you get confused, look for that sample mean first. If you find that sample mean, then you can find the population mean easier. So when I fill out my hypotheses, I always have to have my population mean in my hypotheses. Don't use your sample mean. That's not the correct thing to do. So here, remember I talked about it being greater than. So I have the mean is greater than 20.5 minutes. That's my alternative. My null is mean equals 20.5. And that's the way we're going to keep it. We're not going to change it. It's just going to be that way. Okay? So I've broken down everything that's in the the problem for this. Now the next thing I want to do, I've got this up here. I'm going to go put it in my calculator. So let me go grab my calculator and bring it back up. So again, I'm going to pause this and then I'm going to do another video on this so you can see what we're doing. So I'll be back with the next part where we're going to put it in the calculator.